Hello guys, today's LeetCode problem is the sum of all subset XOR totals. So what is the problem is saying that we have been given an array, okay, ARR or nums, and we have to return the sum of XOR of all its subsets. So basically what we have given the array, right, and we have to just take the XOR of all its possible subsets, and we have to return the sum of all XOR totals. So right, this is what they have given us, and this is the definition of subset. So for example, given the array which is containing x1 x2 x3 as elements, so you know, right, what are the possible subsets. So subset can be empty or it can take any of the element, but the order should be maintained. It means that in any subset x2 should come before the x3 and x1 should come before the x2. So this is what it means. So these are the possible subsets, x1 x2 x3 x1 x2 x1 x3 x2 x3 x1 x2 x3, and we have to just the XOR of all the possible subsets. It means that for this it should be XOR x2. For this it should be x1 XOR x3, and this is what something I am keeping at a y5, y4, y3, y6, and what we have to do at last, we have to just return the sum of all this y from y1 to y7, and this will be my answer. So let's understand this with a simple test case given here. What we have given? We have given a 1 and 3. So possible subsets would be 1, 3, 1, 3. Correct? So XOR of 1 is as it is a single element, so 1. XOR of 3 would be the 3 because it is a single element. And XOR of 1, 3 would be 0, 0, 1, 0, 1, 1. So you know, right, XOR of 0 XOR 0 is 0, 1 XOR of 1 is 1, 0, 0 XOR 1 is 1, 1 XOR 0 is 1. So 1 1 0, 0 1 1, 0 0, that is 0. So it is a 2, correct? So it will be 2, and we have to return a sum. So 1 plus 3, that is a 4 plus 2, that is a 6, and this is the output for this test case as well. And this is what we have to do. So this is a simple problem. Okay, if you have seen, first of all, this is the extra problem that we have to take a XOR of elements and we have to return sum of it. But this is a standard recursion problem. Okay, simple. What we have given, for example, this is the array given to us 1, 3, 2. Right, this is something given to us. How to generate a subsets? That is a question. How to generate subsets? Because you know, right, to generate a subsets we have two choices: take it, non-take it. So this is standard recursion problem where we have two choices: take, non-take. So for example, if I am at any index in function, right, so I have two choices: either take it, so I will take it, so I will do something here, modification in answer. If I will not do something, then I will go to the next index plus 1, and I will keep it as it is, and here also plus 1 would be there. So we have two choices: take, non-take, correct? And this is what we have here as well. So this will ultimately create a subsets for me, and whenever, what is the base case, whenever I am reaching to the end, just retake the sum in some variable, right? This is what it. So we will take a dry run for this. Okay, we will do some dry run. Let's see. Let's say there is one variable call is as a total sum, which would be taking the sum of all subsets of XOR. Okay, so initially I would be at index 0, so I would be index at 0, and this will be my index, and this will be my XOR. So initially XOR will be also 0, correct? Makes sense. Now I have two choices: either take it, so I will go to the first index, or not take it, so I will go to the first index and I will not update XOR, I will keep it as it is. If I am taking the 0th element, that is this, so 0 XOR 1 is 1, so it will be updated. Makes sense? And you know, right, in recursion we used to solve first left subtree. So this is what I will do. Again, I have two choices: go to second index, do something, go to second index, do nothing, keep it as it is, so it will come as it is. Makes sense? Now I have choice here, take. So I have choice to take this. So what was my previous XOR? 1. So 1 XOR 3. What is that? We already saw here, right? 1 XOR 3, something 2. so it will come ultimately 2 here. Makes sense. Again, I have choices here. Go to third index, take it. So once I take this element, second index element, so 2 XOR 2, what would be 2 XOR 2? So which will be nothing but 0 1 0 0 1 0, which is ultimately 0 0 0. So it will be 0 only, because XOR of same element is 0. And if you don't take it, so I will go to the third index, and ultimately this will be as it is. So this is my base case, right? I am now out of the bound, like I am here now. So whenever I am reaching to the end, that is length of the array 3, I will just add it. I will just add this XOR into total sum. So total sum will become now plus 0 plus 2. This 0 plus 2, which is now 2 only. Correct? Makes sense. Now let's try to solve remaining ones. I have two choices here. I go third index and take XOR of 2, that is this one, with this XOR. So 2 XOR 1, right? So 2 XOR 1 would be 0 1 0 0 0 1. So it will be 1 1 0, that is a 3. So of course it will become a 3 here. I have choices. I will not take it, so I will go to third index and keep it as it is. Take non-take, right? So here is a take, here is a non-take. Same for left side is a take, right side is a non-take. Correct? So again 3 1, so I will just add it into my answer. So plus 3 plus 1. Makes sense. Now let's try to solve the right subtree now. So 1 0, I have two choices. Either go to the second index and take it. So first element of is a 3 only. So 3 XOR 0 0 1 1 0 0 0. So it will be 1 1 0. So ultimately it will be 3 only. Makes sense. Not take it. So f of, I will go to second index, I will keep it as it is. So this will be same only if I am not taking it. So ultimately I will go to reach to third index and it will be 0 again. Either I have two choices here again. F of go to third index, take it. So second index is a 2, so it will be as it is, because XOR of 0 with some element is also that element only. Same for this. I will go to the third index, 3, right? 3 XOR 2. That's what I have to do here. So 0 1 1 0 1 0, that is a 1 0 0, that is a 1 only. So 1. I will go to the third index, f of 3, I will keep it as it is. So I have to add this 1 3 2. So I will just say plus 1 plus 3 plus 2, and this will be my answer for it. So this was how you can solve this problem. We could have taken this example as a 516, so you would have got this answer, but still we got this answer, that is a 5 plus 1 6 7 plus 3 10 plus 2 12. So output this for this would be the 12. So this is how you can solve this problem with a simple recursion only. Let me tell you the code. So code for the first of all, the time complexity for this problem would be 2 raised to n, because we are using recursion and we have two choices at every place. So 2 raised to 12 at max in worst case is something nearby around to the 40 something like that, 4000 basically, let's consider. So it is nearby constant only, which would be accepted. So see, this is how I have made it. What I have taken, I have created a helper function which is taking index, the nums array, this array, input array, and XOR, and this is my class variable. Self total XOR will give me the total sum. So index helper function, whenever I am reaching to the base case, that is whenever I am reaching to the end of the array, I am adding that local XOR into my total XOR. I am just returning because I am stopping my further iterations. And again sorry, at every index I have two choices. Either take it, means XOR with it, or don't take it, keep it as it is and go to the next index. This is what I am doing, and total XOR will give me the final sum of it. So yeah, I hope you got it. This was the simple approach only, using take non-take recursion standard approach. So see you in the next video. Thank you. Bye bye.